Hello friends, today we are going to look at the LSTM architecture, specifically based on the nomenclature from the MATLAB Deep Learning Toolbox. Let's get started. This diagram illustrates the flow of data through an LSTM layer with input x and output y with t time steps. In the diagram, ht denotes the output, also known as the hidden state, and ct denotes the cell state at time step t. If the layer outputs the full sequence, then it outputs y1 to yt, which is equivalent to h1 to ht. If the layer outputs the last time step only, then the layer outputs yt, which is equivalent to ht. The number of channels in the output matches the number of hidden units of the LSTM layer. The first LSTM operation uses the initial state of the RNN and the first time step of the sequence to compute the first output and the updated cell state. At time step t, the operation uses the current state of the RNN, ct-1, ht-1, and the next time step of the sequence to compute the output and the updated cell state ct. The state of the layer consists of the hidden state, also known as the output state, and the cell state. The hidden state at time step t contains the output of the LSTM layer for this time step. The cell state contains information learned from the previous time steps. At each time step, the layer adds information to or removes information from the cell state. The layer controls these updates using gates. This diagram illustrates the flow of data at time step t. This diagram shows how the gates forget, update, and output the cell and hidden states. These components control the cell state and hidden state of the layer. The learnable weights of an LSTM layer are the input weights W, input weights, the recurrent weights R, recurrent weights, and the bias B, bias. The matrices W, R, and B are concatenations of the input weights, the recurrent weights, and the bias of each component, respectively. The layer concatenates the matrices according to these equations, where I, F, G, and O denote the input gate, forget gate, cell candidate, and output gate, respectively. The cell state at time step t is given by Ct equals Ft Hadamard product Ct minus 1 plus It Hadamard product Gt, where circular dot denotes the Hadamard product, element-wise multiplication of vectors. The hidden state at time step t is given by Ht equals Ot Hadamard product sigma c, Ct, where sigma c denotes the state activation function. By default, the LSTM layer function uses the hyperbolic tangent function, tan, to compute the state activation function. These formulas describe the components at time step t. In these calculations, sigma g denotes the gate activation function. By default, the LSTM layer function uses the sigmoid function, given by sigma x equals 1 by 1 plus e power minus x, to compute the gate activation function. Thank you.